Hey everyone! Alright, so for our water celebration, we are going to do a bunch of experiments that have to do with water. So, watch this video. It's going to show you how to do these experiments, or it's going to give you another video to watch to show you how to do these experiments. And just do them along with me. They're super fun, super cool. And I'd love to get a video or a picture of you doing these experiments and being a scientist. Right, Ziva? Yes. Ziva wants to see your work too, so be sure to send it to us. All right, let's go to the first experiment. Okay, everyone, so for this experiment, you're going to need a little thing of water, some tin foil, and some paper clips. And what you're going to do is you're going to make a tin foil boat. However you want to make it. I'm going to kind of... Alright, so here's my little tinfoil boat, okay? You're gonna put the tinfoil boat in the water. Now, I'm gonna take my paper clips. I'm gonna put them in one at a time and see how many paper clips it takes to sink my boat. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and look, my boat is still floating. Oh, I have one more paper clip. 10. Yeah, my boat is still floating with 10 paper clips in it. Now, I've run out of paper clips, but you will keep going until your boat sinks. See how many paper clips it takes to sink your tinfoil boat. Well, hello everybody. All right, I have a really cool science experiment we're gonna do today. I have here some water. You can see. All right, and I have some objects here that we are going to drop into the water and see if they sink or go down to the bottom, or if they float and stay at the top. Okay, let's start with this ring. What do you think? Will this ring sink or will this ring float? Let's see if your guess is right. Ready? Oh, it fell all the way to the bottom. It sunk. Okay, so the ring sunk. Let's try the kitty cat spoon. I have a kitty cat spoon here. Do you think it will sink or float? Okay, let's see if you're right. It sunk. All right, gotta pick it up. Ah! Okay. What about this piece of plastic? What do you think? Will this sink or float? Let's see. It floats. See, it's staying on the top. It floats. Awesome. All right, what about my bracelet here? Will it sink or will it float? Let's see. Oh, it sunk to the bottom. Okay, what about my ducky? What about my ducky here? Will he sink or will he float? Let's try it. He floats. My little ducky floats. Whee! Uh-oh, ducky. There we go. Okay, what about a coin, some money? You think this will sink or will it float? Let's find out. It sunk to the bottom. Oh man. Okay. Last one, I have this little, it's called a Funko Pop. It's like a doll, a little figurine. Do you think she's going to sink or float? Let's see if you're right. Woo! She's floating. She kind of does a little bit of both, but she is floating. Look at that. All right. Hope you had fun with that experiment, everybody. Stay tuned for the next one. Okay, so this next experiment is one you might have to wait until summertime to do, because it's a little cold right now and it might not work. What you're going to do is you're going to go outside and you're going to draw a picture on the sidewalk using water. Maybe take a paintbrush outside, dip it in the water, and paint a picture with water on the sidewalk. Now, your picture is going to disappear. How do you think it's going to disappear? What's going to make it vanish? You can also take a timer and time how long it takes to make your picture disappear. Okay. Another step. Try the same experiment on a dark surface versus a light surface and see if the dark surface evaporates quicker. Lots of cool things you can try with this. Okay, but we're exploring water and how it disappears. All right, friends. So, for this experiment, we're going to see what makes ice cubes melt faster. Okay, so what you're going to need is some ice cubes. I have a towel set down to keep my space dry, but then you're also going to need some tin foil, some wax paper, and some plastic wrap. Now, I don't have wax paper or plastic wrap at my house right now, but I do have parchment paper. So I'm going to see what this one does. So you're going to take your ice cubes and wrap them. So I'm going to wrap one here in the tin foil and one here in the parchment paper. Now, I'm going to take my phone, set a timer, and in 5 minutes, I'm going to come back and check on how fast my ice cubes are melting. Okay. All right, my friends, so it's been about an hour, and I wanted us to look at our ice cubes. So first, the one in the tinfoil. You'll see there's a bit of a wet spot on the towel. It has been melting. Wow, look how tiny it got. Now let's do the one in the parchment paper. Oh, this one's really wet. Now, if we look at these ice cubes, right now it looks like the one from the tinfoil is just a little teeny tiny bit smaller, but not by much. But this seems to suggest that tinfoil might melt ice better than parchment paper. You can keep the experiment going and complete it all the way until things are melted. You can try plastic wrap or wax paper like I mentioned. Give this experiment a try. See what you can find out. Okay, friends. So this experiment is also one that you might have to wait until it gets a little warmer outside to do. And this has to do with bubbles. Oh, I love bubbles. So one thing you can do with this experiment is just go outside and blow bubbles because it's super fun. But the big part of this experiment is that you get to stand inside of a bubble. Hey, what you're going to need some bubble soap. You're going to need bubble wands. You're going to need a small kiddie pool that you can stand in, and you're going to need a hula hoop. So, you're going to fill the kiddie pool with the bubbles and place the hula hoop inside of the kiddie pool and the bubbles. Then you're going to stand in the center of the hula hoop and have a friend or family member, some people, pull the hula hoop up over your head. So the bubble should encase or surround you. When you do this experiment, think about, can you do the same experiment with just water? Will that work? Interesting that water has different properties when it's mixed with soap.